Hello, John Talley here with Boats.net. Today we're going to spend a little bit of time going through the different wiring techniques and best practices for installing a bilge pump, regardless if you're using a manual one with a built-in float switch, or one of the new electronic sensing ones. No matter which one you decide to go with, there are certain practices and certain requirements that you need to meet when you're doing wiring, especially down in the bilge. So if you're ready, then we go grab some wire, a pair of crimpers, and we'll dive into this. Now the first one we're going to look at is using the manually triggered bilge pump along with a separate switch, a three-way switch, and then a fuse. Now you can get this and this incorporated into just one switch where it has the fuse housing in it, but I'm going to go under the assumption that maybe you don't have enough room to get this in your control panel, and that switch is going to pop right in. So we're going to do that scenario first. But it is important to make sure that you have an inline fuse, because this is going to protect the wiring in the boat should there be a pinch in the line or something that it grounds out. Because if it doesn't blow this fuse, then it's going to burn that wire below decks, and that can lead to big, big trouble. So first, let's discuss the fuse size that you're going to need for this particular application. As you can see by this chart, it's going to draw somewhere in between 4.5 and 7 amps under full load, depending on the voltage as well. So that is going to require a 10 amp fuse to go inside the fuse holder. Now the other thing you want to take into consideration is the length of the wire that's going to be heading down to the combination of the pump and the flow switch itself. Now if it's under 20 feet, you should be just fine with 14 gauge wire. Now if it's further than 20 feet, you may want to bring that up to a 12 gauge wire just to make sure it has enough ability to carry that additional amperage. Now let's talk about the wire itself. Resist the temptation to use the leftover speaker wire that you had when you did your sound installation. This is all going to be below decks, so it needs to be resistant to heat and fuel and oil and everything else that may be sloshing around there. So you want to make sure that you're using the appropriate U.S. Coast Guard approved wiring for this application. Now for this particular design, a 2-conductor isn't quite going to get it. We're actually going to be using 3 different conductors because we're using a switch that can either run in automatic mode or manual mode. So for that, of course, they make a 3-conductor, which I have an example of it here. Now you've got your fuse and the wire we're going to be using. How do you need to make these connections? Well, option number 1, twisting back the wire, wrapping some electrical tape around it. No, that is not an option whatsoever. Almost as bad, a wire nut. It's completely open to the environment, and it makes a nice little cup for salt water or whatever to get in there and start the corrosion process. Now, the first approved way to make a connection on a boat is using a butt connector, but you want to use one with heat shrink on it. Even better, heat shrink that is gel filled. So when you apply heat to the surface, it shrinks down, makes a bond with the existing insulation on the wire, and creates an airtight seal. That's what you're after. Now you can go one step further and actually use heat shrink with the gel inside, but you solder the wires together and then heat up the actual heat shrink, and then it shrinks down and creates a fantastic connection. On my boat, that's what I do 99% of the time. A little bit more time consuming, but hey, I know that that wire is, for all intents and purposes, one continuous piece because it is completely sealed up. Now, but for today, we are going to go with the simple crimp type butt connectors with the heat shrink. So let's start with our connections at the battery. Now I've found through experience it's best just to put a slight cut into the insulation. Don't go all the way through it, you just have to score it, and it'll actually split it open, because if you go too far, you're going to go into the wires and then potentially cut the insulation, and that's inviting corrosion to get inside. So just a light cut just to score it, and then it'll come apart. Then cut it back. Now the second thing that I do, just a personal preference, I don't particularly like having that rough edge there. So once I get my wires exposed and cut the insulation and the batting out of the way, I will go back with a piece of heat shrink and just finish off the end of that wire to where it has a more professional look. A little bit of extra effort here makes all the difference long term. We'll go ahead and do the same thing to the other end. That way that wire will be prepped and ready to go. Now I don't know about you, but that's the way I want things to look inside my boat. Sometimes the most important parts are the things you can't see until you pull up the floorboards. Now, with that wire prepped and ready to go, let's start with our connections. We'll begin with the battery. More importantly, we're going to begin with the fuse going to the battery. Now what I typically do is go ahead and pull the fuse, which in this case is going to be a 10 amp. That way I can go ahead and make all of my connections without worrying about arcing it somewhere on the ground. Once again, I'm using a crimp type connector with the heat shrink. Also, once you heat them up like this, don't grab the end, it will burn you. All right guys, we've got the main wire prep that's running from our switch location back to the pump, and we'll deal with that wiring in a little bit. But what I want to talk about now is back at the switch location. Now, industry standard, it varies on this. There's a couple of different ways you can do it. You can use a regular three-way switch where it's on in one position, off in another, and then momentary hold would also connect it as well. Now, an alternative is just to use a two-way switch, simple on and off. So let's talk about the installation of just the two-way switch. Two-way switch is here with the manual mode, and then your float represents your other switch. So if you want to manually run it, you've got an on-off switch, which allows it to manually run. Down with the float, if the water gets too high, the float closes, power flows through, turns on the pump. Pretty simple. Now there's only one drawback to this. This float line is always live. So there's no real way to turn this off except to turn off the battery source itself. So what's the downside of using just a two-way switch? Well, there's only one I can think of. I mean, it is an extreme positive that you don't have to think about, well, did I actually put the switch in the right position when I left my boat in the water? It's got a straight path going through that float to get to the battery and run your pump. But there's a downside. What if it becomes stuck? That way the pump's just going to run, and these pumps do not like to run dry. Eventually it will burn it up. I've seen it happen before. Actually, I heard it in the boat next to me. The boat, it was just running, and it was not pumping out any water. It was because the switch is stuck. Now the other alternative is to use a three-way switch. Now with this scenario, you can actually completely isolate the pump away from power, putting it in the off position. You can activate it by putting it in the momentary position and then empty the bilge. The other is to put it in the run mode, which sends power to the switch, and then when the switch gets activated, then it turns on the pump. Up to you as to which way you want to go. The one advantage with this is, yes, you can completely isolate your pump if you have a float switch failure. The downside is, if you don't have this in the run mode, it cannot turn on the pump. It won't happen. So, which way do you want to go? For this particular application, I think we're just going to install the three-way switch. Now that you've seen the diagram for the two-way, we're going to go ahead and install a three. Now here's where it's important to make sure that you didn't throw away your wiring diagram, because depending on the manufacturer, the location and the function of each one of these connections on the back of the switch itself, they may be different. On this particular one, it is a lighted switch, so you have this additional ground that has to be activated or grounded so that light will turn on. The center part, that is where your power from the fuse is going to come in, and then these are basically your two outputs, one for momentary and the other for the run mode. So let's start wiring this up. We will go ahead and prep the negative wire coming from the battery. Now, let's go ahead and get what will be our manual. We'll make that the green. Our flow switch, which will be our white. You can go either direction. It's just different colors. It's up to you which way you want to apply it. Now here's where it could get a little bit tricky. What we want to do here is give a common point for the ground. So what we're going to do is combine these, or tap into these points right here. Now our switch uses a 1/4" spade type connector, and that's what you're going to need to get. Once again, it has the heat shrink already on it. So here's our power coming in. This is our ground. Now these two, manual is going to be green, float switch white. So that completes the helm wiring. Now let's work our way down to the pump and the switch. Let's grab one side of our switch. As I said, that was going to be white. And now that pathway is going to go parallel with the manual wire, which is the green. Now both of these are going to have to go under one connector. And the other important thing is to make sure that you leave enough length on these wires to bring it up out of the bilge, because even though they're going to be sealed, we do not want to run the risk of these staying in the bilge water. Now this is the one that would be the most important to make sure it has the gel filled heat shrink, because with two wires it makes it more difficult to get it to seal up. And that goes to the positive of our pump. Last but not least, we need to get the ground going back up. Now heat shrink it all down. Now we can go ahead and connect up our battery. We can put in our fuse. See, we are in the on mode right now. So when I lift the switch, water comes in, pump turns on. Now, off position. Nothing there. Water comes in, she's not going to turn on. But you can hit the momentary and it'll come on. So with this particular switch, when this gets activated, it knows the current is flowing, turns on the indicator. So this is the scenario with a pump, a switch, wired to a 3-position switch back at the helm. And what we're going to look at next is a integrated automated pump, which basically combines these two together. And but we're going to wire it through a 2-position switch, lighted. So let me go grab that and we'll go through that process. Let's go ahead and remove that fuse. There. Now we'll just set all this out to the side. So there we are. Battery source, switch, boat cabling, pump. Now how's it going to go together? Well, let's start by creating our connections that are going to be down in the bilge, just like we did the other one. We're going to go ahead and prep it, strip it back, then seal it up to where this cable's ready to go. Once again, 20 feet long, max for this size. Otherwise, you're going to need to bring up the gauge size. All right, same scenario, but here's the difference. We're going to take our manual, or run, in this case, and it is going to piggyback on the fuse side. So it is a direct line running back to the pump. Now we accomplish this by putting it on the same terminal that's going to the switch itself. Now our negative, we need to parallel that also into the switch because this is a lighted switch and it needs that negative to turn that light on. So just like we did on the other switch, our negatives are going to go together onto one terminal. So that just comes back to the single eyelet that goes to the negative post of the battery, or whatever distribution you're using for your particular application. Now that leaves us one last wire, and this is going to be your manual. So our negative needs to go up here. Now keep in mind your switch may be different. The battery source goes here. Our input goes here. And then our load goes down there. Now let's head down to our pump. Our negative, our manual, which means it's going to be going through the switch, which in this case I used the white wire to pull that off. Last but not least, this represents the wire going to the switch inside the pump. So in essence, it's going all the way back straight to the battery through the fuse. So this is a constant connection. Now, for somebody that's absent-minded, this may be the way to go, and you're just trusting that that float level switch never fails. Now let's see what we've got. So we're in the off position now. Let's go ahead and put our fuse in. Now we're wanting to run it manually. Flip the switch. She's going to just sit there and run. Now, if we put this into some water to activate the switch on the inside, it would run. Let me go get a little bucket of water. We'll lower it down in there, see if I'm right. Let's see what we end up with here. It should trigger. There it goes. See how that light came on? It senses it. Now when I lift it out, it's going to run for about another 5 or 6 seconds at least. Light's still on. All right. Thank you. Light's off. Well, there you go. If you never want to have to worry about making sure that your switch is on so your pump will work, this is the way to go. The only bad part is I can't turn it off. The only way would be to either disconnect it from the battery, or if you were going to a battery disconnect switch to turn the boat off, or the power to the boat rather. All right guys, let's talk about this last pump real quick. It actually wires up exactly like this integrated pump with the build switch inside of it. The difference is this does not have a switch. It has electronic circuitry to where it turns the motor on every so often, and if the amperage is high enough, which would indicate that the pump is having to work, is going to continue to run until that amperage drops down. That means it's pumped all the water out, and then it shuts off. Now if you want to be able to sleep at night using this type of scenario, knowing that it's going to work and that pump's not going to just run continuously because the float got stuck, this may be the best alternative to go to. Well listen guys, if you need any of these parts or pumps or switches for your boat, why don't you come see us at boats.net and we can get you taken care of. If you have any questions or comments, leave them in the section below and I'll do my best to answer them. And hey, if you like what you see, why don't you go ahead and hit that subscribe button, that way you can keep up with whatever I'm working on next. Listen, we just want to say thank you for shopping here with us at Boats.net, and we will see you in the next video. Y'all have a great day.